Okay, today we take a look at right triangle trigonometry, and for the most part you learned all this in geometry, so this is going to be kind of a quick one and a lot of review. So here's a right triangle. We know we have an angle of 40 degrees and looks like 2,000 feet, and we want to find this missing value x. We're going to have to use one of our trigonometric ratios to do that. So we need to find out what relationship this 2,000 is to this 40 degrees. We know this is the opposite side relative to that angle. And this side happens to be opposite the 90-degree angle, so that's the hypotenuse. Opposite and hypotenuse use the sine ratio, so we take the sine of 40 degrees, set that equal to your opposite, which is 2,000, over your unknown x. Thus, x is equal to 2,000 over the sine of 40. Now, when you plug this into your calculator, you have to make sure your calculator is in degree mode. So let's go through how to do that once again. Now, the default setting of your calculator puts your calculator in what's called radian mode, and we'll discuss what that is in a little bit. So if I open up my calculator, I notice that I look down and I see that here I have highlighted radian and then degree. What I need to do to set my calculator in degree mode is to move that over and hit enter. Then the next thing I'm going to want to do is type in, or go back to my main screen, so go quit, and then take 2,000 divided by the sine of 40 degrees. And then hit enter, and I end up with roughly 3011.4. And that would be in feet. Next, we'll go and find two missing sides for this triangle. I notice that I have this 25 feet and 64 degrees. 25 happens to be the adjacent side relative to that angle, and h is the opposite, and m is the hypotenuse. So I can go about this a couple of different ways. I can use a sine ratio to find my opposite, or a tangent ratio to find my opposite, and then use Pythagorean theorem to find the hypotenuse. I can do a whole slew of things. What I think I'll do is I'll do this. I'll say the tangent of 64 degrees is equal to the opposite, which is h, over the adjacent, which is 25. And then what I'll also do is I'll say the cosine of 64 degrees is equal to the adjacent, 25, over the hypotenuse, which is m. So in this case, all I have to do is take 25 tan 64 to get my h value. In the other case, I need to take and find 25 over the cosine of 64 to get my m value. So 25 tan 64 is about 51.25. That's in feet. That's going to equal h. And then 25 divided by the cosine of 64 is about 57.03 feet. Let's move on to our next example. So here I have a word problem, and this is what typically gives most people difficulties. I've got an amateur radio operator builds a 75-foot vertical tower. So what that tells me is I have something vertical that's 75 feet. And I want to find the angle of elevation to the top of the tower from a point 50 feet from the base. Well, there's the base, and there's my right angle, and this is 50. Now, they talk about an angle of elevation. What an angle of elevation is, pretend this is somebody's eye. Your sight line is at a horizontal. So this is your sight line. And if you were to look up, you would make an angle with your sight line, and that is your angle of elevation. If you were to look down from your sight line, you would make an angle with that sight line, and that's called your angle of depression. So the angle we're looking for is this angle here. Now, I have the opposite and the adjacent relative to that angle. So that is like a tangent ratio. So the tangent of some theta value is equal to the opposite over the adjacent. Now, in order to get theta by itself, we have to use our inverse. So the inverse tangent of 75 over 50 is going to be equal to theta. Now all we have to do is pop that into our calculator. Once again, let's take a look at that calculator. And in this case, the inverse button comes from hitting second tangent. And then you're going to have to take and make sure that fractions in parentheses, the calculator will put that there for you. So I take 75, divide that by 50, close those parentheses, making sure you're in degree mode, hit enter again, and I get roughly 56.3 degrees. So theta is about 56.3 degrees. Let's move on to the next example. Angle of depression from the top of a lighthouse. Well, let's say this is the lighthouse, and I'm at a sight line at the top of it, and I'm looking down because we're talking depression to the water. Here is the angle they're speaking of. And they're telling us that the lighthouse is 250 feet. So here's my right angle. Here's my angle of depression. And I have a ship that's 2 miles offshore. Well, 2 miles, if this is in feet, and then we're talking 2 miles, that's 2 times 5,280 feet. So this is my foot. So what that gives me is roughly 10,560 feet. And they want us to find this angle of depression. But if this is my triangle over here, how am I going to find this angle? Well, you can do this a couple of different ways. I like using my geometry. I know these two lines are parallel, my line of sight and my ground. So these are alternate interior angles, and this angle theta is the same as the angle of depression. So once again, I'm going to use a tangent ratio and say the tangent of theta is equal to my opposite, which is 250, over my adjacent, which is 10,560. Again, to find theta, I'd have to use my inverse notation to do that. So I'll now take and plug that into my calculator and see what I end up with. And after plugging into the calculator, we get theta is equal to roughly 1.35 degrees. Our last example of the day, we want to take and determine the height of a tall tree if this woodcutter, well, here's my tall tree, let's say, stands some distance from the tree, and he looks at an angle of elevation and sees the top of that tree at 40 degrees. Then he moves 30 feet closer. So he's going to start here and walk 30 feet closer. and look up again. And this time, he has an angle of elevation of 50 degrees. And what we want to do is we want to find the height, h, of this tree. Well, we can do this a number of different ways. What I think we'll do is, let's take and do a little substitution. So I know that the tangent of 40 degrees is equal to the opposite, which is h, and I'm looking at the big triangle, over the adjacent side, which is a combination of the x and the 30 feet. I also know that the tangent of 50 degrees is equal to the opposite, which is h over x. So now I have a couple of options. And the option I think I will use is I will solve for h in both cases. So what I have is I have h equaling x tan 50, and I have h equaling tan 40 times x plus 30. So now there's a system. I'll set the two equal each other and solve for x. So I have tan 40 times x plus 30 times tan 40. I distributed basically the tan 40 into that, is going to equal x tan 50. Now, like in all algebra problems, we're going to want to get all the unknowns to one side. So let's do that. Let's take and say 30 tan 40 is equal to x tan 50 minus x tan 40. I'm going to factor out an x, be left with tan 50 minus tan 40, and that's all going to equal 30 tan 40. Isolating, x will then equal 30 tan 40 over tan 50 minus tan 40, which now turns into a calculator problem. And after plugging all that in, we end up with roughly 71.38 feet. So that's all I've got for you today. Here's 3 problems that I want you to go ahead and solve and put on the form. We'll see you tomorrow.